right, so the day you've finally been waiting for is here. We are starting to talk about graphing absolute values. So whenever you hear or see in the textbook when it says graph or the absolute value parent function, so whenever you see parent function, that is just the basic graph of y equals, or f of x equals the absolute value of x. So whenever you're graphing these, there's a couple different ways, but if all else fails, you can always resort to making a table. So on here, they did a table for y equals absolute value of x, the parent function. So when you plug in -3, you get 3, -2, 2, -1, 1, and so on. And it gives you this graph right here. So this graph has the vertex at the origin. And if you notice, the slope of each line is up 1 over 1, up 1 over 1, and then up 1, left 1, up 1, left 1. So the slope of each line is either 1 or -1, and that's the parent function. All right, so now the example says, what is the graph of the absolute value function f of x equals the absolute value of x minus 2, and how is this graph different from the graph of the parent function? So let's go ahead and make a table. So you have your x value, and then you have your y, which would be the absolute value of x minus 2. Okay, oops, where did I throw that extra absolute value? Let me put that away. Okay, so let's go ahead and pick some numbers. Let's pick -3, -2, -1, 0, 1, and 2. And we are going to plug those in for x. So when you plug that in, the absolute value of -3 is 3, minus 2 would give you 1. Absolute value of -2 would be 2 minus 2, so 0. Absolute value of -1 is 1. 1 minus 2 would be -1. Absolute value of 0 is 0, so 0 minus 2 is -2. Then you would have 1 minus 2, -1, 2 minus 2, which would be 0, and then 3 minus 2 would give you 1. So as you can see right here, the numbers repeat, and that is normal, and it looks like -2 is going to be the center of that, the y value of -2. So let's go ahead and graph these. So you've got -3 up 1, -2, 0, -1, -1, -2, or 0, -2, 1, -1, 2, 0, and 3, 1. And as you can see, this makes a perfect V shape. So let's go ahead and connect. Oops, I forgot. And it has arrows because they go on forever, so don't forget that part. And there is the graph of f of x equals the absolute value of x minus 2. So that was the first part. And so the second one is, how is this graph different from the graph of the parent function? Well, if you look up at the top, that parent function, the vertex is shifted. So it is shifted. There's a shift of down 2, or you could say 2 down. Or you could say a vertical shift down 2. That's sometimes you'll see that. Okay, let's look at the slopes. Have the slopes changed any? Nope, it looks like it's still up 1 over 1, up 1 over 1. So that would be the only thing that would be different than the parent function. So there's one answer. Okay, here is this lovely diagram right here, and I'm not saying that sarcastically. I really like this diagram. If I were you, I would screenshot this or keep track of it so you can reference it later, because if you can memorize this right here, you are going to have your life, it's going to be so much easier whenever you're graphing these absolute values. So if you have, let's just talk about each piece. I know it's kind of blurry, I'm sorry. So if you have a vertical translation, which is what we just had, vertical, so if it's a plus a number, it would go up. If it's minus a number, and this is on the absolute outside of the absolute value symbol, it goes down. Okay, the horizontal translation is a little bit different. If it is inside the absolute value, if it's x minus something, you go right. It's kind of the opposite of what you would think, so you got to keep that in mind. If it's x plus a number, you go left. All right, and then the vertical stretch. So a stretch means it gets more narrow. This has to do with like the slope of the lines. So a vertical stretch, if x is greater than 1. So if it's a number bigger than 1, it can be a fraction, but if it's bigger than 1, it gets more narrow. And if it's a compression, or you see a lot of times the word shrink, I'm going to use those two interchangeably. Like shrink and compression are the same thing. The book uses compression. I like the word shrink. So that means it's getting wider. Okay, and so if that's whenever the number outside of the absolute value in front of the absolute value is a fraction between 1 and 0. All right, and the last piece of this is the easiest one, I think. If there is a negative in front of the x coordinate, in front of the absolute value, this is a reflection, so it goes upside down. And then if you don't, this one's not very common, but if it's in the y-axis, so it would be like if it starts here, you would reflect it over here. So it would be reflected across the y-axis. That one's not as common, but this first one definitely is. You see that one a lot. Okay, so let's use our diagram to help us on this first one. Multiple choice, which of the following of the graph is the graph of y equals x plus 2 and absolute values plus 3. So x plus 2, that would be up here, that would be a shift left. So let's write that left 2. And then if there's a plus 3 on the outside, that would be up 3. So we're looking for a graph from the origin that has moved left 2 or up 3. Left 2, up 3 looks like letter D to me. So letter D would be the answer. Okay, now let's talk about these vertical compressions or shrinks. So you'll see the word factor. So a vertical compression or shrink or stretch, you see it by a factor of, so this one is wide. Notice how it's really wide. So this is going to be a shrink / compression. And then let me tell you what the factor is. So you just find the slope of the line. So it is, start here, goes to here, up 1 over 3. So the factor is 1/3. And that makes sense because up here it said our vertical compression is if the number is between 0 and 1. So this is a fraction between 0 and 1, so you would do y equals 1/3 absolute value of x. And that's it, because it still starts at the origin. All right, this next one also starts at the origin, but notice it's more narrow. It looks like it's been stretched up. Somebody took it by the top of it and just stretched it up towards the top of the graph. So this is a stretch, and you find the factor the same way. So this one looks like it's up 3 over 1. So the stretch by a factor of 3. So this graph would be y equals, the 3 goes in front of the absolute value, that equals 3 absolute value x. So you can see right here, it's going to be a vertical stretch. It's more narrow when a, the number in front of the absolute value, is greater than 1. In this case, it is 3. All right, so this next one, we don't have to graph it. So we need to compare the graph of each to the parent function. So that's the basic function right here. So this one, if it's plus 3, sorry, I'm kind of plus 3 on the outside, that's going to be a vertical translation up however many amount, and it looks like it's 3. So this is a vertical shift. You can say translation or shift. I'll take either one. Up 3. All right, this next one is a shift. It shifts 2 ways. So I'm going to do shift, shifts, if it's inside the absolute value, the x plus 3, look up here, x plus 3, that would be left. Okay, so left 3, so left 3, and then if there's a minus 1 on the outside of the right, so on the right, it would be down 1. And this last one, this would be there's a number greater than 1 up here, so we know it's going to be a shrink, remember? Greater than 1, or sorry, I said shrink, I meant stretch. It's going to be a stretch, so it'll be a stretch of a factor of 4. Now, I didn't forget about that negative sign. That's just a different translation. So when you have a negative sign, go back up here. If it's on the outside, it's a reflection in the x-axis. So that's what you'll write. Reflection in the x-axis. Okay? All right. And if you wanted to graph, go over to Desmos graphing calculator, and you wanted to check this because you're really struggling, if you want to guess, and okay, this is my advice. If you're struggling, I want you on these homework problems to write down what you think the answer is, and then go over to Desmos and actually graph the graph and see what it looks like and see if you were correct or you were wrong. Maybe that'll help you, and if you do that over and over again, maybe that'll help you start getting the hang of this. All right, the next one, it says, without graphing, so we're not going to graph, identify the vertex, axis of symmetry, and transformations from the parent function. Okay, so the vertex. If you think about this graph, if it's shifted, this one, let's just do the transformations first. So this is a shift of, if it's -2, go back up to your diagram if you need to, or it's going to be right 2, and then the plus 3 out here is up 3. So that's a 3. Okay, so if you shifted right 2 and up 3, that would give you the coordinate of the vertex right there. Think about it. If you're at the origin and you shift right 2 up 3, that gives you the vertex of 2, 3. Okay, so vertex of 2, 3. Now the axis of symmetry is always going to be the x coordinate of your vertex. Okay, so x coordinate of your vertex, and you write this, it's a vertical line, x equals 2. So I went ahead and just graphed this just on Desmos so you can see visually what I meant. So here's the vertex at 2, 3. Oops, let me write on it. 2, 3. You can see the axis of symmetry is this line right here. That's a vertical line at 2. So x equals 2 is how you write it. So that's what I mean by the axis of symmetry is always the x coordinate, because the vertex is always going to be what it splits the graph into 2 equal pieces, or the axis of symmetry. So always go off the x coordinate of the vertex. Okay, so this next one. Sorry, it's getting crooked now. Sorry, I hit the wrong button. Okay, so this next one, let's use a different color. Okay, so this would be a shift of down 2, and then if it's the fraction in front of the absolute value, it's less than 1, so that means it's going to be a shrink or compression, I'm going to say shrink, by a factor of 1/4. Okay, so that's the transformation. So now let's do the vertex. Well, if you just shifted it down 2, the vertex would be 0, 2. The axis of symmetry would be your x coordinate, remember, so it's x equals 0. And that's it. These are going to be hard at first, but the more you do them, the more you're going to get better at it, I promise. Okay, this next one looks like when it's inside the absolute value, that's either left or right. And so x minus 4 would be a shift right 4. And you also have that negative sign out front. So do you remember? That is the reflection in the x-axis. Okay, so the vertex, if you start at the origin and you shift right 4, that would put you at 4, 0. So the axis of symmetry is going to be x equals 4. All right, next one, we're almost done. I think, yep, perfect. So write an absolute value equation for each graph. First, let's start by finding the vertex. So the vertex on this one looks like it's at 1, 3. So we're gonna have f of x equals x, and if it's shifted over to the right, so it shifted right 1, it'll be minus 1. And then up 3, so plus 3 on the outside. Looks like the slope is 1, so that's fine. It's not flipped upside down, so that is all you need to do right there. This next one we can see is flipped upside down, so this will be f of x equals negative something. I'll leave some space because it looks like there is a shrink or stretch. So we have x, looks like the vertex is at, this graph's kind of hard to see. It looks like 0, 0 to me. So the vertex at the origin, nice, so that's just x. There's nothing on the outside. So now we get to figure out what the slope of this line is. Looks like it goes to here. So that would be down 3 over 4. So negative 3/4 out front. All right, this last one. Vertex is at negative 2, negative 6. So it's going to be negative 2. So that would be left 2. So you're going to have x plus 2. Down 6 would be minus 6 on the outside. Now it looks like it faces up, so there's not going to be a negative out front. But let's see, it looks like it's up 1 over 2. Up 1 over 2. So it would be 1/2 in front. All right, again, be patient with these. I know they take a long time to get used to. Please look at this diagram. I promise this is like one of the best diagrams I've ever seen for these, and they really help you study this. Have it handy when you're doing your homework. Don't give up. Keep working. If you're not sure on your homework, you can always check Desmos. Thanks for watching.